Welcome to lesson number 4. We're looking at special triangles, exact values, and a unit circle. However, we're going to be looking at the investigation in class next Tuesday. We're going to be jumping ahead to class example number 1. We're going to be using this chart that you're going to be making in your investigation, which I've already made for you for the purpose of this video. And let's jump ahead to class example number 1. So we want to write the following in terms of a reference angle, and then we want to determine the exact value. So if I have sine 210 degrees, first of all, we want to determine where it's going to be. So if I draw my Cartesian plane, and if I have 210 degrees, we know it's going to be somewhere over here. And if I find my reference angle, because we want to write it in terms of a reference angle, then we would have 210 degrees, subtract 80 degrees, and that equals 30 degrees. And in this quadrant, the sine ratio is negative. So sine 210 degrees is equal to negative sine 30 degrees. Now, if I look at what sine 30 degrees corresponds to with my chart here, sine x, where x is the angle, sine 30 corresponds to a value of 1/2. But since it's negative sine 30, this is going to correspond to negative 1/2. Now, if we look at our calculator, we could double check. So sine of, negative sine of 30. I don't want to do inverse sine. So negative sine 30 is equal to negative 1/2, or negative 0.5. Cosine 30, well, I want to take the same approach. Cos 300 is going to be in this quadrant. Now, if I have cosine 300, then we want to find out what our reference angle is going to be. So 360 degrees minus 300 is equal to 60 degrees. And the cosine ratio is positive in this quadrant. So cosine 300 is going to equal positive cosine of 60 degrees. Now, I don't have to type it in my calculator. I can again use my chart where I have 60 degrees. It's also going to equal 1/2. Tan 225. Now, tan 225 is going to be in this quadrant, quadrant 3, where my tan ratio is positive. We're going to have the reference angle, 225 minus 180 degrees. We have a reference angle of 45 degrees, which again is positive, but tan 225 is equal to tan 45 degrees. And if we look at 45 degrees here, for my tan ratio, that's equal to 1. Without using technology, determine the exact values of theta, where cosine theta is equal to negative root 3 over 2. And we're going to want to use this chart again for the rest of this lesson, essentially. But we want to find out where this quadrant is going to exist. So if I have a negative cosine ratio, then that means that it can't be in quadrant 1 and it can't be in quadrant 4, so it has to be in either quadrant 2 or 3. And what we'll want to do is determine what our reference angle is based off of that value of cosine theta. So the way this works is I'd look for root 3 over 2 on my chart as it relates to cosine. So cosine, root 3 divided by 2, is a reference angle of 30 degrees. So I have a reference angle, and that's equal to 30 degrees. Now, since it's in either quadrant 2 or 3, then my angle for theta is going to be 180 degrees minus 30 degrees, which would give me 150 degrees, and also 180 degrees plus 30 degrees, which would give me 210 degrees. So the point P of negative 3 and root 3 is on the terminal arm of angle theta. Without using technology, complete the following question. We want to draw the angle in standard form. and mark the point P on the terminal arm. So in standard position, if I'm starting from my origin, I have my x value of -3 and my y value of positive √3. So we know that my angle is going to be somewhere in quadrant 2. So there's point P on the terminal arm, and the coordinates are -3 and square root of 3. And we're going in standard position. So that's part A. Part B, we want to state the values of x and y and the value of tan theta. So my value of x, as we mentioned earlier, is -3. The value of y is square root of 3. If I'm looking for tan theta, that's equal to y divided by x, or √3 divided by -3. Now, we want to refer to our chart. Now, we're looking for the tan, and where I have √3 over 3, because that's what I'm looking for, √3 over 3, is right here at 30 degrees, my reference angle of 30 degrees. But the actual value of tan theta, we could just, we're just looking for the value of tan theta, is √3 over 3. And sorry, in part C, we're actually going to be stating the reference angle. So this is where I want to use my chart. And if I look at, again, where √3 over 3 was for tan theta, that was at 30 degrees. So my reference angle was 30 degrees. And the actual rotation angle at this point would be 180 degrees. Subtract my reference angle is going to be 150 degree rotation angle. Now we're looking at the unit circle. Now the unit circle is really cool, and it's going to make your life easier for this unit. So one of the alternative methods for determining exact value, you can use that chart, or you can use your unit circle. Now the diagram above shows the triangles that we can make from the unit circle and from the previous investigation. So in each of these diagrams, the horizontal distance x and the vertical distance is y, and the hypotenuse, which is r, my radius, is always equal to 1. All right, so this is always equal to 1. So this shows how we can develop our unit circle. So in this diagram, we have the 3 triangles, 1, 2, and 3, and they're placed in quadrant 1 on the Cartesian plane. And so if this is my first quadrant, and then I have my unit circle, all these points are representing the radius. So if I were to find this point just on like a graph where the radius is 1, so the radius is going to be my y value here, so that would be equal to 1. But because there's no horizontal direction for this point, my value of x is 0 at 90 degrees. However, if I move my radius to 60 degrees, now I have a value of 1/2 for my x value, and my y value is going to be equal to the square root of 3 over 2. And we're going off of the earlier investigation here, right? At 45 degrees, we are going to have √2 divided by 2. √2 divided by 2 and √2 divided by 2 for my x and y values. Again, I'm going off of these triangles right here. For 30-degree reference angle, our x value is going to be √3 over 2 and 1/2, going off of this triangle. And at this point, my value of x is going to be 1. It's going to be equal to my radius, and my y value has no vertical direction, so it's going to be 0. So if we're looking at the actual y values here, as we increase in our rotation angles, we also increase in the distance from x and y. So 1/2 √3 over 2, and this is √2 over 2, and this is √3 over 2. So notice how it's always 2 for my denominator, and my numerator goes up by square root 1, square root 2, square root 3. And it's the exact same trend for my x values. So square root of 2 over 2 and square root of 3 over 2. So now we want to write the lengths of the horizontal and vertical line segments included. So that was what I did here. But now we want to write the coordinates of the 5 points marked. And again, coordinates of the 5 points marked. So how do the coordinates of the points relate to the measure of the rotation angle? Now, what we'll notice here is if I'm looking for, let's say, cosine theta and sine theta, so cosine theta and sine theta as an example, and let me grab my chart here as well. Let's say I'm looking for 45 degrees. So at this point here, and I want cosine 45 degrees. So cosine 45 degrees is equal to root 2 over 2. But that's also just equal to the x value at that point of 45 degrees. So cosine theta, if that were 45, would be root 2 over 2, and the sine in that same position would also be root 2 over 2. So for our trig ratios are going to be equal to the x and y coordinate on the unit circle.